Morning and welcome back. As decided, today we are going to the higher level questions of oscillation, and I hope that you must have revised the theory and solved a few numericals based on oscillation. So we shall start with simple ones, very simple ones. The first question: the periodic time of a body executing SHM is 2 seconds. Okay. The periodic time of the body is 2 seconds. After how much time interval from t is equal to 0? After how much time interval from t equal to 0 means what is asked? Small t is asked after how much time interval from t equal to 0. Will its displacement be half of its amplitude? Its displacement will be half of its amplitude. You have to find that time. So nothing is said about the starting point of the motion, means it starts from the mean position, and the displacement x is a by 2, half of the amplitude. And what is the time taken for that? So simply x is equal to a sine omega t. Omega is 2 pi upon capital T. Omega is 2 pi upon capital T. So a sine omega t. And we have to find the value of this small t. So x is a by 2 is equal to a sine 2 pi t by capital T is 2 seconds. This a gets cancelled. This 2 gets cancelled. So sine pi t is equal to how much? 1 by 2. Which angle has sine 1 by 2? 30 degree. Means this angle pi t is how much? 30 degree. That is pi by 6. So pi t is equal to pi by 6. This pi gets cancelled. So time is 1 by 6 second. Right? So your answer is t is equal to 1 by 6 second. Means starting from mean position in time equal to 1 by 6 second, the particle will move to a distance half the amplitude. But you don't have to do all this. इतना सब करना नहीं है हमको. You can find out in a single step. कैसे? Look at here carefully now. Suppose A and B are extreme positions and O is the mean position. When particle completes one oscillation, the time taken is capital T. So suppose particle starts from mean position, then mean to extreme, extreme to mean, mean to other extreme, and back to mean. That is one complete oscillation that we have seen in the theory. Mean position से motion की शुरुआत हुई, mean to extreme, extreme to mean, mean to other extreme, and back to mean. That is one complete oscillation, and time taken for that is capital T. Suppose if the particle completes half oscillation, means mean to extreme and extreme to mean, half oscillation, the time taken will be obviously t by 2, half of the periodic time. If the particle completes 1 by 4 oscillations, means from mean to extreme, mean से निकला और extreme पे गया, means 1/4 oscillation, the time taken for that is t by 4 for one oscillation, t for half oscillation, t by 2 for 1/4 oscillations, t by 4. But if the particle moves from mean to suppose point P, which is mid between O and B, मतलब OP distance कितना है? A by 2, This is a by 2. So if the particle moves from mean to mid, तो इसका आधा नहीं होगा, t by 8 नहीं होगा. Why not? Because the speed of the particle goes on changing. At the mean position, the speed is maximum. As the particle moves away from the mean position, its speed goes on decreasing. It goes on decreasing, and at point B, it becomes 0. Extreme position पर speed होगी 0. Then it turns back, starts moving, speed goes on increasing, speed goes on increasing, and when it reaches the mean position, the speed is maximum. तो यहाँ पर speed maximum है, कम 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 होती जा रही है. Means from O to P, the speed is more, and from P to B, the speed is less. So from O to P, less time will be taken. Speed यहाँ पर ज़्यादा है, इसलिए O से P जाने में कम समय लगेगा. Less time will be taken, and from P to B, more time will be taken. The time taken from O to P is T by 12. कितना टाइम लगता है? T by 12. And from P to B, it is T by 6. यहाँ पे कम T by 12, यहाँ पे ज़्यादा T by 6. So time taken from mean to mid is T by 12, and from mid to extreme is T by 6. अगर इस फॉर्मूला में हम ये वैल्यूज डालें, इस फॉर्मूला में, okay, so you'll get this T by 12 and T by 6. We don't have to go into that. वैसे आप चाहे तो ट्राई कर सकते हो. X कितना लेंगे? A by 2, A sin 2 pi T by T. So you get T by 12, and this one will be T by 6. Now coming back to our question, the particle is moving from mean to mid. So from mean to mid, what time will be taken? T by 12. That is equal to, T is given to be 2 by 12, that is 1 by 6 seconds. So remembering this, you can directly find that the time taken from mean to x equal to a by 2 is 1 by 6 seconds. Clear? Next question says, a particle executes SHM of amplitude 25 centimeter and time period 3 seconds. Amplitude is 25 centimeter and time period is 3 seconds. What further it says, what is the minimum time required for the particle to move from 2 points 12.5 centimeter on either side of the mean position? A and B are extreme positions. O is suppose mean position. The amplitude is 25 centimeter. The time taken to move 12.5 centimeter on either side. मतलब यहाँ से mean position की इस साइड 12.5 सेंटीमीटर और इस साइड 12.5 सेंटीमीटर. मतलब यहाँ से यहाँ तक जाने के लिए और यहाँ से यहाँ तक जाने के लिए. मतलब mid to mid. Simple. The time taken from mid to mid, because amplitude is 25, 12.5 means this point is mid. So time taken from mid to mid. Very simple. कुछ लिखने की भी आवश्यकता नहीं है यहाँ पर. अभी जैसे हमने किया था, यहाँ से यहाँ तक कितना समय लगता है? T by 12. यहाँ से यहाँ तक T by 12. तो total time will be T by 12 plus T by 12. That is 2T by 12 or T by 6. That is equal to, T is given to be 3 by 6. That is 1 by 2 second. So time taken to move from 12.5 centimeter on either side of the mean position is how much? 1 by 2 second. Direct answer. The vertical motion of a huge piston in a machine is approximately simple harmonic. एक पिस्टन है, उसका मोशन कैसे हो रहा है? वर्टिकल मोशन. and that vertical motion is approximately simple harmonic. Okay, with a frequency of 0.5 per second. The frequency of that oscillation is 0.5 per second, means 0.5 hertz. Okay, a block of 10 kg is placed on the piston. A block of 10 kg is placed on the piston. What is the maximum amplitude of the piston's SHM for the block and piston to remain together? कितनी ज्यादा से ज्यादा एम्पलीट्यूड होनी चाहिए, ये जो पिस्टन एसएचएम में है, इस एसएचएम की ज्यादा से ज्यादा कितनी एम्पलीट्यूड होनी चाहिए सो दैट द ब्लॉक एंड द पिस्टन दे रिमेन टुगेदर. इसका मतलब क्या है? सपोज द ब्लॉक इज जस्ट केप्ट ऑन द पिस्टन एंड द पिस्टन इज मूविंग अप एंड डाउन. अगर इसकी एम्पलीट्यूड ज्यादा हो गई, if the amplitude is more, the block will leave the piston. So the question is, how much should be the maximum amplitude so that the block, it doesn't leave the piston? That is your question. Now, when the block is moving, the piston is moving up and down, vertical SHM, suppose A and B are extreme positions, O is the mean position. When the block is moving upwards, okay, in which direction? Suppose the piston is here, the direction of weight is vertically downward, mg, and acceleration of this piston, it is moving upwards. Acceleration कौन सी direction में है? Upwards? No. The acceleration in SHM is always directed towards the mean position, whether the piston is moving upward or whether it is moving downward. In any case, the direction of acceleration is towards the mean position. So the acceleration is also downwards. So when the block is above the mean position, its weight and the force due to acceleration ma both are downwards. When the piston is here, its weight is acting downwards and acceleration is upwards towards the mean position. So ma is upwards. Means here what will be the net acceleration? यहाँ पर net acceleration होगा g minus a will be g plus a. यहाँ पर नेट दोनों एक्सेलरेशन सेम डायरेक्शन में है, सो हियर नेट विल बी g माइनस a, हियर इट विल बी g प्लस a इन ऑपोजिट डायरेक्शंस. तो पॉसिबिलिटी क्या है? नीचे ब्लॉक जो है वो छोड़ देगा पिस्टन को या ऊपर? ऑब्वियसली ऊपर, क्योंकि अगर आपको याद है, व्हेन द लिफ्ट इज एक्सेलरेटिंग, at that time its weight is reduced. कब होता है वो? when both the accelerations are in the same direction. same case is here. इसका मतलब ये कि जब g minus a इक्वल टू हो जाएगा 0, यानी कि g इक्वल टू a हो जाएगा. when g minus a equal to 0 means when g is equal to a होगा, at that time what will happen? the weight will become equal to 0 and the block will leave the piston. Correct? So the force acting on the block, the force which is acting on the block is its weight. If that weight becomes equal to mass into acceleration of SHM, acceleration of SHM. So when weight is equal to mass into acceleration, at that time the weight will become equal to 0 and the block will leave the piston. Getting the point clear? So now you are asked to find out what should be the maximum amplitude. अब mg equal to mass into acceleration है, कौन सा acceleration? Obviously maximum acceleration है ना, क्योंकि जब mg कांस्टेंट है लेकिन एक्सेलरेशन क्या हो रहा है? चेंज हो रहा है. सो व्हेन द ब्लॉक लीव्स, एट दैट टाइम एक्सेलरेशन इज मैक्सिमम. So this m gets cancelled. G is equal to acceleration maximum is a omega square. A is the amplitude, omega is the angular velocity. So A is equal to G upon omega square. That is G upon omega is 2 pi n, 2 pi by t or 2 pi n because n is given. So omega square will be 4 pi square n square. So the maximum amplitude will be G upon 4 pi square n square. Pi square की approximate value हम क्या लेते हैं 10. G की approximate value 10. So this G and pi square gets cancelled. So A will be equal to 1 upon 4 into n square, 0.5 square. 1 upon 0.5 square is 0.25. 0.25 into 4 is 1. So maximum amplitude will be 1 meter. That will be your answer. So what is the hint here? Any object when kept on a surface, when does it leave the surface? It leaves the surface when the normal reaction or the reaction becomes equal to 0. When the reaction is 0, that time it will leave the surface. And when will the reaction be equal to 0? When it is equal to downward force. Correct? So from this you decide, you come to this conclusion that if the acceleration of the body, if it is equal to G, acceleration due to gravity, when acceleration of the body becomes equal to acceleration due to gravity, but remembering that not in opposite direction, in the same direction, acceleration should be in the same direction as that of G. तो acceleration अगर G की direction में है और acceleration equal to G है, at that time its normal reaction will become equal to 0 and it will leave the surface. So you have to remember this hint.